Thank you and good afternoon, everybody. I will tell you about new countrywide three-dimensional datasets that we have created for Estonia. But let's start with a short introduction to Estonian land board. Land board, or Maamet, as we know it in Estonian, it's a government agency under the Ministry of Environment. And acting as a national mapping and cadastral agency, it has two main fields of activity. One is geomatics and another land cadastre and real estate. Land board is also the largest producer of spatial data in Estonia. And so all these departments you see on the slide, they create a lot of data and we have to collect it, manage it, and present it. And for data visualization, we have usually used maps. So let's have a look at some of these maps. For example, we have administrative map or soil map or geological maps or large scale and small scale topographic maps. And we have also hybrid map and many more. And all of these are really beautiful pieces of art. We have even received honors on our map design. But all these maps have one fundamental problem, that they are flat. They show the data only in 2 dimensions, and that is not enough for today's users. A lot of use cases need full 3D view of data, something like you can see here. Of course, this is not Estonia. It is actually a screenshot from Swiss geoportal, and I included it for 2 reasons. First, I think Swiss top engineers have created one of the finest 3-dimensional GIS systems in Europe, acting as a role model for us. And also the landscape in Switzerland is really beautiful, but you can only fully appreciate it in 3 dimensions. But returning to Estonia, maybe it's not so exciting as Switzerland. We are actually looking at the highest peak of the Baltic states in southern Estonia. But still, it's fully 3D, and you can look around the corners of buildings or behind the hills. So how did we get here? The important date was the last day of March this year, when during one day, Estonia gained 2 new web applications showing countrywide information in 3D. And one was developed by Estonian Land Board and another by Estonian Ministry of Economic Affairs and Communications. And as you can see from the screenshots, they share a lot of data and there was a good cooperation between the organizations during development. And I invite everybody to visit these websites and surf yourself in 3-dimensional landscape. Of course, these apps were not the first ones we have in Estonia. For years, we have had architects and urban planners and local authorities creating 3-dimensional data, also visualizing it. The most advanced application is provided by Italian city government, and I'm really looking forward for their presentation tomorrow. But still, all these previous applications are showing only part of the area. But now we have countrywide coverage for 3D data. And let's look closer at these apps. The land board application should look very familiar. It is standard ArcGIS web app with standard buttons and menus. And all the data is residing in ArcGIS Online Cloud. But we still like to call it a prototype because we have some ideas how to make better in user interface. And also some data layers are experimental. But more on that later. And here you also see the 3D data we have in this application. There are terrain, buildings, trees, and LiDAR point cloud. And for buildings, we have 2 layers with level of detail 1 and another layer with level of detail 2 models. The difference is that LOD1 shows flat roofs for each building, while in LOD2 you see the actual roof shapes. The digital twin is another different application, and it's actually part of the larger e-construction platform that is being developed to help Estonian construction sector. As you see when going to their website, the initial view is in 3D map, but there is a button in the lower right corner that you have to press to switch on the 3D view. And the 3D view shows you much the same information, terrain, building models, but there are also additional information like flight restriction zones in 3D. And there are plans to include also underground objects like pipelines and cables, and also plans to integrate it into the process of issuing building permits. The building layers in digital twin are also in two different layers. On the left, you see the same LOD2 models developed by Land Board, but on the right side, there is LOD1 models developed from the data in Register of Construction Works. And as you see, there are some missing data in Register, but also some additional data. The blue models here on the image here, they are not for actual buildings, but buildings that are being constructed currently. So we can peek into the future with this app. But let's now tell more about data. Basically, all the three-dimensional data that we have developed in Estonian Land Board is based on airborne laser scanning. We do the scanning ourselves with our own aircraft and LiDAR device. We have two standardized altitudes for data collection. In urban areas, that gives us about 18 points per square meter, but in rural areas, only slightly more than 2 points per square meter. The LiDAR point cloud contains a huge number of data points, but it's actually in itself a very good three-dimensional data set. And here you see not an orthophoto map, but actually billions of data points that are colored using orthophotos. But of course, you can change the visual style, like showing elevation or showing data collection tracks, or showing the classification of points into terrain or buildings or vegetation or water. Based on this point cloud from LiDAR, we have developed a digital terrain model, and the exact same model is used in both of these new applications. And you see here just one part of it. Also, the building models are created from LiDAR point cloud, and we also use here the building footprints from National Topographic Database. And as you see, here is shown the AHA Science Center in Tartu. I think we got the models pretty realistic comparing to the aerial photograph. And the process for creating the models is fully automated. No manual work included, but there is one problem that this automated process cannot include textures right now. All these models are shown in dull gray color, but we are looking into making also textured models in the future. Right now, we have one manually textured model to show you in one experimental layer, and I think it's much more beautiful than these other gray boxes. But the geometry is, of course, not enough. We have a rich set of semantic attributes for our building models. There included data includes addresses, types of buildings, metadata about data collection dates and model building dates. Also, importantly, links to several national registers, like address data system and construction work register and more. And there is also linked to website showing oblique aerial images. So when you are clicking in some building, the information box pops up, and you can click on the links to open in different browser tab, these registers, or for example, this oblique area imagery from all cardinal direction showing that particular building. The last data layer that we have produced 3D models is for vegetation or models of trees. This is actually also experimental. We have not covered the whole area of Estonia yet. We are working on it. And these models of trees are created using ArcGIS, first using the basemaps, 3D basemap solution. We have taken from these billions of LiDAR data points and created a normal two-dimensional point layer out of it, where each point represents a trunk of a tree. And then for this point layer, we have two different visual styles using the preset layers feature in ArcGIS, showing different 3D models, thematic or analytical models in one case, and more realistic tree models in another case. And it's also, as you heard before, already used in Rail Baltic project, it's exactly same models of trees and also buildings. So for conclusion, what are the lessons that we have learned from this 3D development process? First, of course, that there is very much interest in 3D data in society. We have quite many requests and trying to fulfill them all for the data. But we still ask you, everybody who is using our data, please do tell us about your use cases, how you use our data, and how we can make the data even better in the future. Second thing is that dealing with 3 dimensions is harder than dealing with only 2 dimensions. Well, this is not exactly news, but I can say that it is really true. But fortunately, we have nowadays powerful computer hardware and software that we can provide you country-wide data layers. And finally, there is a question about standards. Actually, there are quite many different standards for 3-dimensional data. And sometimes the number of standards itself creates problems. Usually there are only a few problems inside GIS community when exchanging data, but when exchanging data with different communities, I mean like video game producers or architects, there are more problems with different standards, different file formats and services. And I really hope that in the future we will get better interoperability also for 3-dimensional data. And now for the final slide, I will show you a quote from one of my favorite books. You all know that today technology is moving very fast, and every day you have to learn something new. And I can say on behalf of Estonian Land Board that we are keeping our promise to create accurate and up-to-date data for everybody. And now we are also creating 3-dimensional data. And we are ready to run even faster if needed, and maybe creating 4-dimensional data in the future. So thank you, and please visit these websites.